Good afternoon. Thanks for coming to this talk. My name is Yong Tang. I'm a software engineer working for Infoblox. In today's talk, I will discuss about machine learning in Infoblox and how we use CoreDNS and service discovery to resolve the issues we encounter. First, some background about Infoblox. Infoblox is a network and a security company specialized in DNS, DHCP, and IP address management. In recent years, Infoblox augmented its on-premise solutions with a new SaaS offering, with a focus on machine learning-based threat intelligence. We use machine learning extensively for the detection of DNS-related malware attacks, such as data exfiltration through DNS tunneling, DGA attacks, and fast flux botnets. Today, those machine learning algorithms are deployed on our product, protecting Infoblox customers. Inside the Infoblox, we have a small machine learning research team, and there is no dedicated machine learning DevOps team or machine learning infrastructure team to support it. For that reason, we prefer to use services provided by cloud vendors, such as EMR or SageMaker on AWS. But from time to time, we still need to deploy our own TensorFlow clusters, and there are some reasons for that. First, TensorFlow is a very fast-paced project with many features added every week. There is a gap between the version provided by SageMaker and the latest version of TensorFlow. Second, TensorFlow is a very extensible framework. You can add a new feature with TensorFlow with user-defined ops. For example, we develop a user-defined ops of Kafka Reader streaming data. We can only deploy Kafka Reader on our own TensorFlow clusters until it's being merged into TensorFlow release. Like I said, we have a very small team, so our scope is very limited. Eventually, we want to bring up and down a cluster with just a few commands, so that even machine learning researchers could launch clusters on their own. We use CoreDNS plugins to achieve our goal. CoreDNS is a DNS server with a focus on service discovery. It's a CNCF incubating level project, and the Infoblox is a sponsor of it. CoreDNS integrates with Kubernetes, and it's likely CoreDNS will be the default DNS server engine for Kubernetes very soon. Finally, CoreDNS has a plugin-based architecture, which means it could be easily extended with customized plugins. And that's what we are doing in our case. This is a diagram of a TensorFlow cluster. When TensorFlow starts, the whole cluster information about every node has to be pre-specified beforehand. But node IPs may not be available yet. Instead, we could use CoreDNS to expose predefined host names. This allows us to specify the cluster information even before the launch of the cluster, and no additional configuration is needed after that. We implemented several CoreDNS plugins with different use cases. One implementation relies on AMI launch index of the EC2 instance. Launch index is part of the instance metadata and could be obtained by querying AWS API. Its method allows you to avoid having a persistent storage, which is a big advantage. Another implementation utilizes etcd. It does require persistent storage, but then you don't need to depend on AWS anymore. We also pack the TensorFlow and the CoreDNS into a cloud init script. Now, deploying TensorFlow clusters could be so easy, such that you can just deploy it with one command. This is a good win for machine learning researchers. And also, this is a great example to demonstrate the usefulness of CoreDNS and service discovery. Essentially, CoreDNS gives you a distributed system with 80% of the functionality of a distributed system as just a fraction of cost. That's pretty much for my talk. Thanks.